Assalamu alaikum everyone. How are you all? Am I audible? आवाज आ रही है मेरी ठीक से? You guys can tell me in the chat.
Yes, we can hear you.
Okay, awesome. So I guess we should start now. Okay, so my name is Fazia Khatib. I'm a student of Faber Medical College, Peshawar. So today we're going to learn about analysis using RevMan and all of the statistical terms, forest plot जो हमारे पास बनते हैं उनको interpret कैसे करते हैं, all of the statistical and analytical aspect of meta-analysis हम आज discuss करेंगे. तो let's start with analysis. Analysis होती क्या है? तो I'll share my slides also, but right now I'd prefer कि आप लोग I should give you a brief intro. तो just focus on what I'm saying right now. अच्छा, तो analysis basically जब हम मेटा करते हैं ना, तो at the data extraction stage हमारे पास raw data होता है. Raw data कैसे होता है? Because meta analysis is a secondary research study, right? उसमें आप बाकी स्टडीज का डाटा लेते हैं, उसको एनालाइज करते हैं एंड यू गेट योर रिजल्ट्स. ठीक है ना? तो once you get your results तब आपके पास सेंस बनती है. दैट्स द एंटायर पर्पस ऑफ कंडक्टिंग अ मेटा एनालिसिस. जैसे कि लेट मी गिव यू एन एग्जांपल. लेट्स से कि एक नया ड्रग इंट्रोड्यूस हुआ है फॉर द ट्रीटमेंट ऑफ ओवेरियन कैंसर. तो अभी
Excuse me, ma'am. Excuse me, ma'am. We cannot see the screen. We cannot see your screen.
I've not shared the screen. I'm just talking right
Hello?
now.
Okay. And I request, like, it would be good for everyone if you can speak in English for better
Oh,
understanding.
sure. Totally okay with me. I'm so sorry.
Thank you.
Okay. So
Thank
let's
you.
restart.
Thank you.
Okay. So let's restart with, the definition of analysis. So the purpose of conducting the analysis is to convert the raw data which you get after extraction into data which has some meaningful results. Like, for example, your topic is a new drug for the treatment of ovarian cancer. That's your topic. And let's just say you have 4 studies. So, 2 of these studies are saying that this drug is significantly superior to the previous drugs. By significantly superior, I mean that they are saying that this drug has major benefits over the previous treatment options. But there's an issue. The third study is saying that both drugs are comparable. They're absolutely the same. Neither of them is superior. So it doesn't matter if you use the new drug or the old one. And the fourth study is saying that the previous drug is significantly superior to the new drug. So we have 4 studies originally, and all 4 of the studies have different results. So can you identify a trend on the basis of this? How are we supposed to find out which one is actually better? Now, being humans, our judgment is very biased, right? So what we do is that we extract the data, we input it into RevMan, Review Manager, which is basically the software which we predominantly use for meta-analysis, and it gives us our results. Those results are, mathematically based. They do not have any bias, and they tell you which drug is superior, or are they all the same. Anything. The results could be anything. And on basis of those results, you know exactly what treatment option should be adopted in the future. So that's the entire purpose of the analysis. It's basically the most important part of conducting a meta. Okay, so let's start with the analysis. The software, as I mentioned, we use is RevMan, Review Manager version 5.4. You can download it by searching it on Google and uh, on Google, and they have cracked versions. So download those and you will get it. Right now, I'll open it on my screen, and side by side, we're going to, learn how to carry out the analysis and all of the relevant terms and the terminologies and everything, right? Okay. So what we do first of all, let's open an extraction sheet first. I'm assuming you guys have, done extraction, right? Yes. Okay. Awesome. Let's open an extraction sheet. Okay. So as you can see, this is the extraction sheet, the baseline characteristics, and the outcomes. Now let's keep this here and open RevMan. How many tabs open? Okay, we're going to open RevMan. Now this is the interface that you will get once you open it. We can open a previous review, but since we are learning from scratch, let's start with a new one. We'll close this, go to File, and we click New. Okay, so then we get this new review wizard. We click on Next. And since, most of our meta-analysis are based on interventional reviews, like you basically test any surgical options or any, new medicines, new drugs. So intervention review it is. We keep this as intervention review, right? Next. Okay, so here you write the name of your intervention. The name of my intervention is, let's just say, drug A. And the health problem is, give me an example, guys. Any health problem. Okay, I'll take cystic fibrosis. That's our health problem. Now, next, you click full review, not protocol, full review, and then finish. So now you've created a new review. What will we do after this? Okay. First of all, you include your studies. You see the studies and references option here. All of this is not concerned with us, okay? From here till here, it's not concerned with us. The only two things that we usually use is studies and references and data and analysis. So let's come to studies and references first. Right? Sorry. You double click on studies and references, and then you right click on reference to studies. Double click on studies and references, and then right click on reference to studies. When you guys download it, it would be better if you, practice it side by side while watching the recording, because it helps so much practicing it, and it's really interesting once you get the hang of it. It may seem complicated at first because you might think there are so many steps to this and I might forget them, but once you get used to it, it's very easy. And we'll click on Add Study. You'll keep this as included studies and click Next. Now here we mention the study ID. Let's open our extraction sheet. And our first study is Jan 2022. Let's write Jan 2022. Next. Next again. Next. Add another study in the same section. Okay. If you are not done adding new studies, so you click add another study in the same section, and if you're done, you click nothing. So since we're going to add more studies, let's select this. Continue. So we have the same new study wizard again. Let's look for the other study, Jensen 2021. So basically, we're repeating the same steps over and over until we're done. May 2021. May 2018. Now the last one. Okay, so finish. Now what do we have here? We have all of our included studies. See, we have all of them here. Doesn't matter how many you have, if they're 20 or 30, you have to mention all of them over here. So is it clear up till now? Should we repeat something? Uh, Could you recall the steps? Of course I can. Let's recall the steps. Why is this not happening? What we did first was we clicked file. From there we clicked new. You'll get this wizard. Here you'll select intervention review. Next, you'll write the name of your intervention here and the name of the health problem here, like your population. If your population is patients with heart failure, then you'll write heart failure over here. Here you'll select full review and here you'll finish it. Since I don't want to create this review, I'll just click cancel. So once you're done with that, what you will do is that ignore all of this. This is not relevant to you up till tables. Then you'll click on studies and references. You'll double click on studies and references. Then you'll right click on reference to studies. Okay. Here you'll select add study and included studies. Keep it as included studies, don't change it. Next, here you'll write the name of your study, ABC 2023, 2024. Next, add another study in the same section. You'll click continue and you'll get the same wizard again. So you repeat the process until you're done for all of your studies. I hope that makes sense now. Why was the year 2024? It was just an example. It's not important for it to be 2024. 2020, basically the year refers to the year that the study was published in. So if I write um, Johnson 2023, that means that the last name of the first author was Johnson and the year of publication was the year that I mentioned. Should we move on? Yes, okay. So now that we have, added the references for all of the studies, we add the data for the forest plots. So do you guys know what forest plots are? Any idea? Okay, so I'll tell you guys. Forest plots are basically a graphical representation of your results which are generated by RevMan. So, do you guys want to learn and understand more about forest plots after we learn how to generate them or before? I feel like we learn better if at if first we generate them and then we, explore all of the different components of forest plots, but it's totally up to you guys. Okay, it's up to me. All right then. I'll just make sure that we all learn. I also learn a lot when I teach, by the way. Whatever is best. Okay. So I say first we should learn how to generate them. And then we can, explore all of the individual components, what they mean, what is their significance. All right. So let's get back to RevMed. Now that we've added all of the references to the studies, what we will do is, I said that we're only concerned with studies and references section and the data and analysis section. So this is done. We'll move on to data and analysis. The purpose of this section is for you to enter the data that you extracted and it analyzes it and it gives you your results, which you can, write in your results section in the manuscript, and then in the discussion and conclusion section, you elaborate it further. So what we do here is that we right click, on data and analysis. Here you'll select add comparison. So let's say our comparison is over the scope clip versus through the scope clip for gastric ulcers. That's the name of the comparison. The name of the comparison is your intervention versus your control for your population. That's how you name your comparison. You click next, and here you select add an outcome under the new comparison. Continue. Okay, before we proceed with this, do you guys know what dichotomous and continuous outcomes are? Yeah, okay. So it has been taught to you, right? Okay, I'll
I
assume it.
think I think I think if you can explain, I think that would be better.
Okay. I'll give you
Thank you.
guys a review of it. So basically, we have two main types of outcomes when we are doing a meta-analysis. One is dichotomous outcomes and one is continuous outcomes. So why do we have this classification and what does it signify and how do we proceed further with the two different types of outcomes? Let's have a look at that. So basically, dichotomous outcomes have two possible results. And what do I mean by that? Let's talk. Let's talk about biological sex. Okay. So we have two biological sexes, right? Male and female. So it's sort of a binary variable, right? It has two possible quantities or two possible results. It's like a 0 and 1 situation, like a yes and no situation, right? That's why it's called dichotomous. And if you have trouble remembering it, just have a look at its name, dichotomous. So di means two, right? Just remember, if it has die in the start, that means that it is the variable which has two possible results. Now let's talk about a dichotomous outcome. What could that mean? So someone said that they know about dichotomous outcomes. So Kalimullah, could you give us an example of a dichotomous outcome? Yes, of course. Any yes or no question, perhaps? Um, like I'm asking, what could be a dichotomous outcome? You guys have done extraction, right? There you had different outcomes for which you extracted the data. Okay, I'll give you guys an example. My example is, it's literally the best example which I use everywhere. It's mortality. So if you are looking into mortality, you you know, for mortality we have two results. It's either yes or no. The person either passed away or he did not. So it's like a 0-1 situation, either 1 or 0. Did he pass away or did he not pass away? You have two possible results with this. So there are two emphasis on the two possible situations. That's why mortality is a dichotomous outcome. And how do we assess dichotomous outcomes? We assess them by event, total, that's it. Event and total. How many people passed away out of how many total people? Do you guys understand? Yes. Okay. What about everyone else? All right. If you guys have any questions, you can mention them in the chat box. Okay. So that's a dichotomous outcome. And for dichotomous outcomes, when we are generating, yes, sure, I can repeat it. Okay. So for dichotomous outcomes, we have two possible results. Is it interrupting for everyone? Maybe, okay. Haris, you may have a connection issue, so you might have to look into that, but I'll gladly repeat for you. So pay attention right now. For dichotomous outcomes, we have two possible values. Those two possible values are either yes or no. So the example that I gave was for biological sex, male or female. There are two possible values, right? You can't add a third one. So that's a dichotomous variable. Okay. Now let's consider an outcome, a dichotomous outcome. An example that I have is mortality. So why is mortality a dichotomous outcome? Because it has two possible results, either yes or no. Did the person pass away or did the person not pass away? Two possibilities, just two. That's why it's a dichotomous outcome. And when you are making the extraction sheet or when you are doing the data extraction, you have two possible situations. Either the okay, how many of your participants suffered from mortality? How many of your participants passed away? So in that situation, what we use is event and total for extraction of data for dichotomous outcome. I'll even show you guys the dichotomous outcome. Okay, let's look at this 30-day mortality. Okay, I'm hoping it's visible. I even zoomed in. So this is the intervention group, this is the control group, this is the name of the outcome. So as I mentioned, mortality is a dichotomous outcome. For intervention, the count, which is the count of the event, size, total number of participants in the intervention group. Same goes for the control group. The count and the size. Now, here, this means that out of 50 patients, 2 patients passed away. Out of 48 patients, 3 patients passed away. And 45 patients did not pass away. So, two, two possibilities. Now for continuous outcomes. Let's talk about weight. So let me ask one of you guys. Haris, am I audible to you now? Yes, okay. So Haris, I'm going to ask you a question about weight. Is it possible that all 10 people in a group have the same weight or have either like two possibilities for weight? No, exactly. So is weight the same as, gender when we are talking about continuous and dichotomous? Do they have the same possibilities for results or not? Okay, they don't. Maybe, maybe not. They don't. So what this means is that for age, for weight, for BMI, and for many other variables and many other outcomes, we have a range of results, so many different results. One person will weigh 45 kilogram, another person will weigh 78, another person will weigh 92, the fourth person will weigh something else. There will always be some sort of discrepancy between all of those variables, all of those values. So it's a continuous range of values, right? So that's why we classify it as continuous variable. Okay, is this point clear? Yes. Okay, let's see an example for it, for continuous variables. Yes, here we have it. Hospital stay. Now, why is it a continuous variable? Because many people will have different values of hospital stay. Some might have stayed for 10 days, some might have stayed for a month, some might have stayed for 20 days. So it's a continuous outcome. And how do we quantify it? We quantify it always by using mean and standard deviation. Mean and standard deviation for continuous outcomes, along with the total number. Same goes for the control group. Mean, standard deviation, and the total, right? This is how we quantify continuous outcomes in our extraction sheet. And this is what we require when we're inputting the data for a continuous outcome in RevMan. We will demonstrate this now and you guys will understand it better. I'd like to, make one point clear, and that is that some studies, they do not report their, you know, the outcome in mean and standard deviation directly. The outcome might be in median and a confidence interval might be given or an interquartile range might be given. So you always have to convert it into mean and standard deviation because if you don't, RevMan does not process median or confidence interval and everything. This is the only acceptable input that we require. How do we do that? Yes, we are getting to that part. So what we do is that, wait a second, how do I remove this from here? Okay. We open meta converter. Yes, open this. So the data has to be quantified. We won't Wait, let me have a proper look at your question. I'm sorry, I don't understand your question. What do you mean, would that include lab results? Like the readings here. Masab, I hope I'm pronouncing your name correct. Okay, so the data that you take, it's from the article itself. And whatever the article is reporting, you have to mention that. If the article is saying that 5 out of 25 people died, you will write 5 in the event arm and 25 in the control arm. And secondly, for continuous outcomes, if the article is reporting that the mean hospital stay was 15 days and the standard deviation was 2.5, you will write 15 in the mean column and 2.5 in the standard deviation. And the number of patients total 25, let's just say it is, so you'll write 25. That's how it is. It's completely based on the that. Okay, what we were looking at meta converter. This is meta converter, guys. Now, median and interquartile range to mean and standard deviation. Open. Let's just say I have a median of 25.33. I'm just making values up for making you guys understand. It's 16.34. Sorry, 16. And this is 30.2. Sample size of the group is 45. Calculate. Here you are, your mean and your standard deviation. Now you take the mean and enter it into the extraction sheet and the standard deviation and enter it into the extraction sheet. I'll even write the name in the chat box so you guys can remember it. What's Q1 and Q3? Okay, Q1 and Q3 is a range and it's called interquartile range. It's basically the two different points in the middle of which your true median value exists. Is that clear? Okay. Another point I'd like to mention about the extraction is that you have to be very careful and very considerate of the units that the study is using. Let's just say that hospital stay is the outcome you're looking at. And one study, it's reporting it in days, and another study is reporting the hospital stay in months. And two different people are doing the extraction. Can't Revman calculate? No, it can't. Unfortunately, it does not have that feature, not that I know of. But you have to do it by yourself. Even for Revman, even for R, which is another software that we use, you have to calculate it by yourself. All right. So I was talking about units. Let's just say one study is reporting the hospital stay in days, and another study is reporting the hospital stay in months. Okay. And one participant is doing the data extraction for the first study and another is doing the data extraction for the second one. And both of them are not coordinating with each other. And one writes um, the hospital stay for the mean hospital stay for study A was 45 days, and another patient, sorry, and the other person who's extracting the data writes that the mean hospital stay was 1 day, when in fact it's 1 month. The unit is different. So the person who's doing the analysis is a third different person, and he considers that both of them are mentioning days. both of the extractors have mentioned the mean in days. And he puts that data in RevMan, and the entire analysis is wrong because the people who were doing the extraction were not considerate of the units that the data was reported in. So it's just a tip from my side that please be careful with the units. It's better to mention it when you're extracting the data. So it's easier. And at the end, you can convert them. Either convert the days into months or months into days. This is actually a genuine mistake that happens because for one of my studies, what the group members did was that the outcome was units of red blood cells transfused. And one person, for some of the studies, the data was reported in ml, and for some of the studies, um, the data was in units of RBCs transfused. Both very different units, and both are not interconvertible. So that the analysis was entirely wrong. And we didn't realize until after we had submitted the study. So that's a serious mistake. Yes, of course, I can tell you about Q1 and Q3. Q1 and Q3 is basically the interquartile range. And by interquartile range, we mean that these are two extremes, and in the middle of these two extremes somewhere exists your true value, which is your median. Okay? It's better not to get into the details of this because it's not really concerned with us. We fabricate it. We fabricate what? So, yes, if the units are not interconvertible, we remove it. No, we don't fabricate it, Haris. It is calculated by the study, by the original study. We have software for everything.